If you are also looking for professional certified structural engineering services or courses, then don't forget to check link in description of this video.
Hey guys, welcome back to another tutorial on SAP2000, and in this tutorial we will be focusing on how to do modeling in SAP2000. That would be our primary goal in this video. So in this video I will be making you aware of those tools that are quite useful for modeling in SAP2000. So for this video I have chosen this building. Its total height is of around 210 feet. It has 2 basements, 1 mezzanine, and 15 typical stories. So, first we will be having our 2 basement, then we will be having our ground floor, then mezzanine, and then further stories. Total height of the building will be around 210 feet. The column sections that we will be using in this building will be following 48 by 48 inches, 40 by 40 inches, 36 by 36, 24 by 24 up to these heights. Slab that we will be using would be of 7 inches thick. Beam size I have taken just as the purpose of this video is just to make you aware of the modeling of the SAP2000. So I have taken just this beam size of 10 by 27. Obviously, if you have to learn the science behind it, so you need to go and check out my SAP2000 course on Udemy, whose link is given in the description below. In that course, I have covered in detail about how to carry out design and analysis using SAP2000 of steel buildings. So you can go and check out that. That is a detailed course. I will not be going much detail into this video because I have to cover it all for you. So if you want to learn this software in detail, so go and check out my SAP2000 course, whose link is given in the description below. So compressive strength of, coming back to our video, compressive strength of beam and column will be 4 KSI, and our shear wall thickness that is in the middle will be of how much? It will be of 5 KSI. And basement wall thickness will be of 8 inches. So I think so you have clarity on what we are going to do today. So let's proceed with SAP2000 and start modeling this building. Click on SAP2000, go to File, New Model. Now as you will click on New Model, so this window will appear in front of you. If you want to again learn in detail about this window, go and check out the course, whose link is given in the description box below. For this video I will be choosing FPS system, that is pound fit. Default material library I will be choosing United States, and then click on grid option, grid only. Now as you click on grid only, so this window will pop up in front of you. Now if we look into our building, so it's clearly that we don't have equal spacing. Instead of that we have 18 feet in the first grid, then 24 feet in the next. So by default, SAP2000 does not give us here option of entering the custom grid spacing. But what we can do for now, we can enter the equal spacing. Then when we will go into the model, we can change that from there. So first of all, how many grid lines are in X direction? So this is your X direction. Your grid lines are 1, 2, 3, 4, 5, 6. So we have 6 grid lines in our X direction. Then how many grid lines in Y direction? This is your Y direction. How many grid lines? 1, 2, 3, 4, 5, 6, 7, 8. 8. Now if I talk about Z direction, so it means how many stories do you have? So see, we will be having 2 basement, 15 typical stories, it means 17, 1 mezzanine, 18. So whatever comes over here plus 1 it, and you will get the total stories. That is total grids for stories. That is, it would be 19. We will cross check it when we go into the model. Then grid spacing, as I told you for a while, keep it equals 24 feet in X direction, 24 feet Y direction, and Z direction 12 feet height. We will change it as per our plan, as per our model later on when we'll be, because we can't do that right now. Click on OK. Now as you click on OK, first make sure that you have drawn your grids in a correct way. Yes, we have drawn our grids in a correct way. Now what we need to do next, the very next step that we need to do over here is that we need to edit our grid data in both XY plane and in Y plane. So what I will, in XY plane and in Z direction. Okay, so what I will be doing, I will be first going to YZ view, then I will be basically making these two floors, that is our basement, of 10 feet, because right now they are of 12 feet. Each of them is of 12 feet. So what I have to make sure, I have to make these first two 12 feet, sorry, 10 feet, this 10 feet, this 10 feet, then 12 feet ground floor, then mezzanine of around 10 feet again, and then typical floors of 12 feet. So what I need to do, I need to go to edit, right click, edit grid data, modify show system, then Z grid data. That's what I am interested in first arranging it. Okay, as per my plan, as per my model that I am going to construct, I have shown you its detail. So first, the very first option that you have to make sure you should be doing is you should be clicking on display grids as spacing. Now once you do that, after that, what you have to do, you have to come to your Z grid data. Your Z1 should be of how much? It should be of 10 feet. Your Z2 should be of how much? It should be of 10 feet as it is basement. Then your ground floor 12. Then your mezzanine should be of again 10 feet. Then click on OK. And let's see whether we have achieved what we desired or not. So here you can see we have our building total height is Z. If I click over there, so in the bottom right you can see Z 210 feet. Here you can see, here you can easily see I'm clicking on that point, so it's 210 feet. Then we have, this is of 10 feet, this is of 10 feet, then this is of 12 feet, this is of again 10 feet, and then we have again 12 feet further stories. So here you can see what we have done. We have make sure that what we aim for, we have achieved that. Our typical stories as per our plan. Okay, now next thing what I will be doing, I will be arranging the grid spacing in XY plane. Again, I will be going to edit grid space, edit grid data, modify show grid, click on display grid as spacing. Then as here you can see, the spacing between A and B should be of 18 feet, E and F should be of 18 feet, 1 and 2 should be of 18 feet, and 7 and 8 should be of 18 feet. So what I will be doing, A and B, it should be of how much? 18 feet. Then E and F, again it should be of 18 feet. 1 and 2, it should be of again 18 feet. And 7 and 8, it should be of again 18 feet. So click on OK. Now go to XY plane. So here you can see we have achieved what we desired for 18 feet between A and B, then between B and C, C, D and EF, between B, C, C, D and EF again 24 feet, then EF 18 feet again. Similarly between 1 and 2 18 feet, then 2, 3, 3, 4, 4, 5, 5, 6, 6, 7 again 24 feet. So now we are done with the grid, arranging the grid data and story data. Our next step would be defining the material. As I told you in the beginning that we will be using two types of material in this model. First material strength would be 4000 psi, that is for our beams and columns. And as far as our shear wall is concerned, so we will be using 5000 psi for that. So click on add 4000 psi is already defined. I will go and define 5000 psi. So click on add new material. I will select concrete from here, United States, NFC 5000 psi. Click on OK. And for slab, I will okay, 4000 psi, 5000 psi. Click OK. Now once you have defined your material property, the next step is to define your section properties. So first we will be defining the section properties for frames. Click on add new property. Guys, the purpose of this video is simply to make you aware of the modeling. That's why I will be not going into the detail how to define frame section. I will be covering that in a separate video. But for this video, I will be just defining them and placing them in the model so that you get aware of the modeling. Because there are few parameters that we need to define while defining the frame, and I will explain you that in separate video, or you can check my detailed course on SAP2000, whose link is given in the description box. So click on add new property, then click on concrete, rectangular. So our first cross section is of 48 by 48. So we write 48 by 48. 48. So it's asking me detail. It's asking me the depth and width. So this is of in feet. So 48 means how much? It means 4 feet by 4 feet. We will be selecting our material 4000 psi. Okay. Now the thing which I was talking about, that there are certain parameters that we need to adjust for our frames, but I will be not discussing these parameters in this video. We will be covering either in the separate video, or you can go and check out my detailed course on SAP2000, whose link is given in the description below. So for a while, just keep it as it is and click OK. Then click on OK. Make sure your design type should be column, rectangular, ties. Okay. Reinforcement to be designed. Always click on this option. Now click OK. So we have defined our first frame section. Then we will be defining our another frame section. Let us click on add new property. Then again rectangular. This time we will be defining of 40 by 40 feet. Sorry, 40 by 40 inches. I'm saying feet. It's 40 by 40 inches. So around 3.3 feet by 3.33 feet. Okay. Click on OK. So we have defined about 40 feet by 40 feet also. Again 4000 psi. Click OK. Now click on add copy of property. And again we have another section of 36 by 36 feet. 36 by 36 feet. So it will be of 3 feet. 3 feet, 4000 psi. Click on OK. Then our last is 25 by 24, 24 by 24. Add copy of property, 24 by 24, 24 by 24. Click on 2. Depth should be 2, and this again should be 2. 4000 psi. Click on OK. So we have defined our column section. Now let's define our beam section. Go to rectangular, and it should be of 10 by 27. Beam. 10 by 27. Depth should be of how much? It should be 27 inches. So in feet it would be around 2.25 feet. And then 10 inches it would be around, in feet it would be around how much? 0.83 feet. Fine. 4000 psi. Click on OK. Now before you go before you proceed further, do remember to click on design type as beam, M3 only. Okay, click on OK. Again, modifier we are not discussing in this video, we will cover in that separate video. So we have defined our frame sections. Then now we will define our slab section, area section, that is slab. First we will define our slab. Our slab of 7 inches, shell thin. In feet, 7 inches it's equals to 0.583 for membrane. So guys, if you need to again learn this thing in detail, go and check out my detailed course on SAP2000, whose link is given in the description box below. 0.583, and click modifiers, we are not discussing in this video. Click on OK. Then define section properties, again area section, and this time we will be defining what? Walls. Add new section. Wall base. First I will define my wall 12, that is my shear wall, shell thin, 5000 psi. Click on OK. Then add new section, wall 8, shell thin. I will keep its thickness around 8 inches, which is around 0.667. Same for bending, 0.667. Material same, 4000 psi. Click on OK. So we have defined our section as well as our frame section as well as our area sections. Now next thing that we are remaining with, now we are good to go for the modeling. That's all we are remaining for this video. So let's proceed with that. So guys, let's proceed with the modeling. Just follow my steps which I am telling you. First we will be modeling the columns. So go to draw special joint. You need to first place the joints, and then from those joints we will extrude the frames. I will show you how to do that. Just follow my steps. So I will select them all. So I have placed the points on this XY plane at level Z equals to 0. Now what I need to do, I need to select these points. I need to go to edit, then in extrude, and extrude points to frame. I need to click this. Now here I have an option to select the section, as I have told you that from column section up to 54 feet will be 48 by 48 feet. So up to 54 feet we have to keep the column section 48 by 48 feet. So I will select 48 by 48. That's my column section size. Now I will be telling here the depth of the column. Now here the depth of the column would be, because our basement is of height equals to 10 and we have two basement, so I will keep the height, that is not dy would be 0, dz would be 10, and since I have two basements, so number will be 2. I will click OK. Now as I click OK, here you can see, let's go click over here and go into the elevation. Here you can see we have got the columns for all our basements. Now next step, what we need to do is we need to make the columns for our ground floor, from ground floor to mezzanine. So it's of 12 feet as I have mentioned over here. Okay, we have two basements. After basement we have ground floor, and then we have mezzanine. So what I will do, I will go to, I will click over here. I will go to 1020. I'm at 20 feet currently, and then I will select these points. Okay, now once I have selected these points, again I will go to edit, extrude points to frame. Again same section, because we are still under 58 feet, so that's why our DZ will be now here 12, and we need just one for one story, 12 feet. So click OK. Now as I click OK, so I will be having my columns for my ground floor. Now once you are done with that, again you need to select these points. You need to go to 32 feet level, select these points. Now once you have selected these points, what you need to do, you need to go to edit again, extrude points to frames. Now here, after this thing, after our ground floor we have mezzanine, that is of 10 feet again, and it's 1. Number 1 mean just for one floor. So here you can see we have got our columns for mezzanine as well. Now since above that all the stories have similar height, so what we can do, we just need to go to your plan, go to mezzanine plan, select these points. Now once you have selected this, so you need to again go to edit, extrude points to frame. What you need to do next, you need to count how many floors are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So, and height of each floor is 12 feet. So DZ will be 12, and we have 14 floors. So click OK. Now as you click OK, here you can see you have got the columns for your complete model. For your complete building, you have drawn the column. But there is a problem. You don't need to do like that. I have just shown you, but the reason why we can't do like that, or we can do like that, but it will again increase our work. Basically the reason I am saying why we can't do like that is because we need to change our column section at different levels of height. So that's why I will undo it. I have to make sure up to 54 feet I have how much column section. It should be 48 by 48. So currently we are at what level? We are at 42 feet level. So 54, then 56. So up to 54 we can go with what? Up to 54 we can go with 48 by 48, but above that we have to change our section size. So click this 42, click these points. Once you have clicked it, you have clicked this, edit, extrude points to frame. Now what you need to do next, you need to keep z equals to dz is equal to 12, but number should be 1. Now once you do that, you will get your column of 48 by 48 section size. Now after that, what we need to do, we need to change from 48 by 48 to 40 by 40, from 54 to 102. Let's see where up to which story there is 102. There's a 66 up to 102. So okay, so mean in the next 4 stories, what should be my column section? It should be 40 by 40. I will go to 54 feet, select those points. Once I have selected those points, what I will be doing next, I will be going to edit, extrude points to frame for next 4 stories, 40 by 40. Click OK. 4, these are 12. So we have got our column section 40 by 40. Now after that, what column sections next do we have? We have 36 by 36 from 102 to 160 feet. Again, you can see from 102 to 160 feet, 36 by 36. So here you can see this is 102, so up to 160 feet. So we can go from there to there. Okay. So in next 5 stories, we have to provide which section size? 36 by 36. So I will be going in on to (102). I will select those points. Now once I have selected those points, what I will be doing? I will go to extrude, replicate, sorry, not replicate, extrude, points to frame, 36 by 36, 5, click OK. So now after that, which size we have to do? 24 by 24 for the remaining. So what I will do, I will again go to XY, at 162 feet, I will select all the points, click on edit, extrude to frame, points to frame. For next, how much stories? 4 stories. And now my section size should be how much? 24 by 24, click OK. Now once you do that, you have defined, and let me change the view objects by section. Click apply, OK. Okay, also click apply for this section. So here you can see we have our this 48 by 48, then 40 by 40, then 36 by 36, then 24 by 24. So we have defined, we have got what? We have got the columns for our complete building. Now next thing that I will be doing is that I will be doing basement walls modeling. Or before that, what I will be doing, let's proceed with first with the basement walls modeling. Then we will proceed with the beams. Then with the shear wall at the last. So what I need to do right now over here, I need to select this one, and then from here I will select wall 8 inches. As I told you, we will be taking wall of 8 inches for our basement, and just click over here. Now once you are done with, so you have defined your walls for this direction. Now we have to model the basement walls for other directions. So what I will be doing, I will be selecting these walls. First let me turn on the fill, otherwise it doesn't look good to me, honestly speaking. So that's why what I will be doing, shells, where is shells, areas, okay, fill objects, click over here. So what I will be doing, I will select these walls, now you know this thing, they are and we have to basically replicate it in positive x direction. And what is this distance? This is around 18, then 24 3 times, then 18. So 24 3s are 72, 72 plus 18, it's 90, 108. So what I will be doing, I will be going edit, replicate. What should be my dy or dz? It should be dx, 108 feet. Number should be 1 capped. Click OK. Now as you click OK, You can turn the now as you click OK, you can go to 3D and you can see your basement walls have been modeled for these two sides. Now for the next two sides, what I will be doing, I will be going into draw developed elevation definition, because I do not have their view on which elevation view on which I can draw. So that's why what I will be doing, I will selecting drawing drop view elevation from here. As I write and leave it, so I have got this view. You can name it as you want. I'm keeping the same name. So select the wall 8 inches, just click it and you are done with your walls. Now for the other direction, what you can do, just opposite to this, what you can do, you can click this. You have got your 5 walls. You can go to click, edit, replicate. How much is this distance? We have, as here you can see, we have 24 into 5. So it's around 24 into 5. It will be 24 into 5. Let me do. It will be around. Let's do that over here. Everything seems to be 24 by 5. Then 156 feet because 218. So it will be around 156 feet. 24 by 5 is 120, then 18 this, 18 this, so it will be around 156. But in which direction? DY direction. So I will write 156 in DY direction. Click apply. Now as I click apply, so here you can see I have modeled my basement walls for my complete building. Basement walls has been modeled. Now once I have modeled the basement walls, my next step would be doing the beam modeling. But before that, what I will be doing, I will be modeling the shear wall, that is the core wall at the center. So close it, go to XY plane. Now this is the region, as here you can see, this is the middle region in which I want my shear wall. So what I will be doing, I will be going to draw developed elevation definition. Then I will be drawing along this complete wall, because I have to draw wall in all 4 directions. So click OK. Now once you click OK, so what will happen, what you can do over here, you will select the wall. Now your wall will be of 12 inches as I've defined, as I've told you earlier. Our shear will be of how much? It will be of 12 inches. You can just click that and you have got your shear wall. Just the one direction is remaining. So for that, what I will be doing, we can just select these walls, go to navigation and SP2. So we will select these walls first. Once I have selected this, I will be going into 3D. Now it's clearly visible that we need in positive Y. They should be replicated in positive Y, but at what distance? So we will check the distance from XY plane. So they need to replicate in Y, and in its distance 24 feet. So I will go to 3D from here, edit, replicate. dy is how much? 24 feet. Click apply. Now as you click apply, so you have also modeled the shear wall for your complete building. Now the next thing that we are left with is the beams and the slabs. So first I will do the beams modeling for which what I will be going on to XY. I will be going on to XY. Then in XY, what I will be doing, XY plane, then XY at Z equal to 10. I will select this draw frame cable option, select the beam, that is B10 by 27. Just drag it over the complete grid and I will get my beams. Similarly, I can do this for all other floors. For simplicity, I haven't defined different section in this video for beams. I've just shown you one section. And do remember, guys, this thing that we are placing right now, continuous beams. If there is a case of secondary beam, so you need to either release the movement or make a pin support. Now let me do it quickly for other walls, for other floors. This complete beams, these are primary beams. Then we'll be just left with the slabs. Doing it quickly. We can also replicate it, but I'm not doing that right now because I've already shown you how to use replicate command. So it's no use over here. It will make our job little bit more easier, but just let me do that way. Do this way. Okay, so I made a mistake. At Z equal to 0, we don't need to have this one, so I've now removed it. Now click on 3D. So you have also defined model the beams for your building. Now the next thing is remaining is your slab. So I will go to XY plane. Then my first slab will be of mezzanine. At Z equal to 0, you will be having mat. Then you will be having your I will be having my next slabs on my first basement bottom, that is 10 feet. So I will be going on to select this one, walls, not slab, 7, same case as the beam. Drag it and drop it. So guys, in this way, here you can see we have easily modeled complete this high-rise building into SAP2000. And the upcoming videos, we will be applying loading onto it. We will also be not covering mesh in this video, but in the upcoming video, we will cover the meshing of the wall, meshing concept. Also modifiers we haven't set. We will also defining realistic sections, and then doing analysis of it as per code. A lot more things are remaining over here, which we will be covering in the next videos. Or if you want to learn this SAP2000 in detail, especially for steel structure, so kindly go and check out our course on Udemy. The link of the course is given in the description box below. You can check out that. It's a complete detailed course. It's a one-stop solution if you want to learn SAP2000. I will highly recommend you to take that course. So here you can see we have also made these slabs. So that's it. We are completely done with our modeling. We can apply by objects. Click on by objects. So guys, here you can see you are good to go. You have defined your complete model in SAP2000. We'll meet you in the next video. Till then, goodbye.